Okay, awesome, awesome. Nice intimate setting, pretty sweet. We're gonna, or I guess first, I just want to say like Project One feedback is coming soon. Like that's just work to kind of go through all y'all's repos. So it's in progress, I promise. Okay, but let's get started with JavaScript under the hood. So a little more in depth than last time. An outline for what we're going to cover is like how JavaScript really functions under the hood, little subtitle of the talk. And that includes the event loop and async behavior. There's also these things called promises and callbacks and a bunch of stuff with that. And then we'll kind of talk about like HTTP and how APIs really work. So how we communicate over the internet. So starting off with the JavaScript runtime environment. From a high level, these four things is like what makes up the JavaScript runtime environment. You have your heap, stack, web APIs, and a callback queue, as well as an event loop. And we'll go into all that, but that's just a super high picture right now. So starting with the heap, this is just where your variables and function declarations live in memory. We don't really mess around with it other than like declaring and assigning variables, but you don't have to really worry about what goes on there. The call stack is actually kind of pretty important. That's a list of the functions that are being ran. So when a new function, when your program hits a new function, it gets added to the top of that stack, and that kind of just repeats. So whatever's on top is what's currently being ran. And as soon as it's done being run, it gets popped off and it moves on to the next one. And that kind of just repeats throughout your whole program. JavaScript is single threaded, and we'll come back to that in a minute, but that just says like only one thing can be happening at a time. So on the stack, it's only going to be doing the thing on top. Yeah, and it can get pretty tall, but yeah, only that top thing will get run. So that's pretty abstract. I guess we can look at a video of what's actually going on with the call stack. So this is a like little contrived example, I guess. It's not really fancy code, but basically we're gonna start here at foobar, run that function, and then we'll try and assign magic to square of 42. That's gonna call square, which is gonna call multiply. And we'll just see like how that actually works with the call stack over here. So okay, really short. Could y'all see that first off?
Yes.
Okay, cool. So hopefully that kind of made sense as it was happening. So we run foobar, which runs square, which runs multiply. Multiply does its thing, returns. Square is done, it returns. Magic is then assigned, and we console log that. So that's kind of what's going on in the call stack. You never mess around with it directly, but it is going on in the background. So kind of moving forward through the runtime environment, we have this web API container. And this kind of holds things that JavaScript doesn't have to do. It's left up to the browser to handle all of this. So it kind of like frees our hands as developers. Just one less thing for us to do. And you may notice it's not on the stack. So that kind of frees up what we can run on the stack. There's also this thing called the callback queue, which once a web API is finished running, it puts a callback function in the callback queue. And we'll see how that links up to the stack with the event loop. So this is really the glory of JavaScript. There's this little loop that's constantly running, and it's checking like, is there something in the stack? If there is, we're gonna run whatever it tells us to. And as soon as the stack is empty, it starts checking this callback queue. So right now it'd just be finishing these things, and then, oh, the stack would be empty. We'll take whatever's in the callback queue. And that lets us do some pretty cool things that we'll get into. Just a quick note, this event loop is always running because we never know when something will be in the callback queue. But we'll talk about that in a second with asynchronous functions. One quick thing about functions, sometimes they can block, which means they kind of block anything else from running. This gets scary if you put a blocking function on top of your call stack, like the one on the right, Nightmare Fuel, like that's a wild true loop. It's never going to finish. So it's going to be blocking your program from ever finishing. Yeah, so like the blocking behavior is why it's called a blocking function. Some examples of these are like network requests, file reading, writing to files, timers. These all just kind of sit on the call stack running. And then with the event loop, we kind of take advantage of synchronous and asynchronous functions. I kind of touched on this earlier, but JavaScript is a synchronous blocking single-threaded programming language. So that means it does one thing at a time, and it does that thing until it's complete. This works most of the time, but it doesn't let us do cool things talking to other computers. So we have asynchronous JavaScript, like little functions, ways to handle these blocking functions. And all of that, all of this runtime environment is kind of the solution to dealing with blocking functions. So we kind of solve this problem by passing a function to the browser to take care of. The browser will say, all right, we're done with this function, throw it in the callback queue, and then the event loop is looking, hey, is this function done? And that really lets us do work while the browser is kind of like running other processes in the background. Again, that's super arbitrary. So there's another quick little example. So let's kind of walk through this code. This is going to run top to bottom, it seems like. So the first function, we're setting a timeout for 3 seconds. And after the timeout's done, we'll run this console log. The second function is thing2, or it posts thing2, thing3, thing4 to the console. So let's kind of see how that would look in action. Okay, right, pretty fancy. Really the highlight of this example is this set timeout. It gets thrown on the call stack. JavaScript looks at it and says, hey, that's a web API. We'll throw it here. The browser is going to do its loading thing with it. And while it's loading, we can start running other functions and lines of code. And then it just sits in the callback queue until we're done with the call stack. And then the event loop takes it and runs that function. So that's basically how the runtime environment works. It is pretty abstract. You're not directly manipulating it while you're coding. Are there any questions about that explanation? There probably are.
Yeah, I had a question.
Yeah, what's up?
How does like JavaScript know which ones to pass to the API and which ones to keep?
Those are kind of defined by the browser. So the browser is like, hey, I know how to deal with timing. I know how to deal with web requests. So I'm pretty sure that that's something JavaScript just knows, like certain type of functions.
So it's just like certain keywords or different things. And the browser will tell it that kind of stuff. We don't have to worry about
No.
anything like that, right?
Not at all, no.
All right.
Okay, I hope that was a decent enough answer. Someone please correct me if that's super wrong. If not, we can move on to promises and callbacks. So what are these? We said JavaScript's a synchronous kind of programming language doing like one thing at a time. This gets bad if you're like trying to make a network request. You have no idea how long that's going to take to get an answer to. So you don't want to just be sitting there like, do we have the data yet? We want to be running other code while that's waiting. And promises and callbacks allow us to do this. They let us kind of take those blocking functions, put them to the side, and continue doing other things until we get a result back. And there are a couple ways we can kind of use these promises and callbacks to solve this problem of blocking functions. The first one is Callback Hell. You'll see why in a second. The second one is using promises with then little functions, and then promises with async and await functions. So Callback Hell, it's kind of a naive approach to solving like callback functions and waiting for something before you do something else. It's not wrong, it's just kind of ugly. So we'll try and avoid it if we can. Basically, it works as like passing a function as a parameter into another function, and then performing the function, the first function as normal, getting whatever value we need, and then calling the function that was passed as a parameter with that, calling that function with the value we generated from the inside function. So it's pretty messy. Here's a kind of example of like what it looks like. On the left, these are just kind of functions. Like it takes in an input and a callback function, does some super basic logging, and then it calls the callback function. So these are all pretty identical, but with Callback Hell, it kind of turns into this if we want to be using the result of the previous function in each, like as a parameter for the next function. And yeah, you get this massive triangle. This example is really small, but if you did this with like 30 functions, you'd be indenting super far out. It's kind of unreadable. Yeah, so we want to avoid this. Are there any questions on kind of how these functions and callbacks are working?
So basically on the left side, you just call them separately, right? Instead of just including all of them under one function.
Are you saying like, how are we calling these, or?
Like, I'm kind of having a hard time understanding how like the right side is like equivalent to the left side.
Oh, sorry. I just kind of declared functions on the left side. So I just didn't want to put it all on one row. But no, we're using these functions on this side. So like get stake would be calling this function here. Does that kind of make sense?
So the parameter of the first function that you run is another function. Is that what we're trying to avoid?
Yeah, in general, that you're right about it being another function, and it's not bad, but it does get pretty verbose with like this is the second parameter to the get stake function. So it's just a little more code than we want to be writing. Okay, so to avoid callback hell, we have this nice .then operator. This uses promises to do roughly the same thing. For our purposes, it is exactly the same thing. It's kind of like a nice syntactical sugar. Like they added it because we suffer from like having to do all those callback functions, but now we don't have to do that. The callback functions use a promise, or use promises for their next parameter. We'll get into promises in a second. But we do have to set those up for this to work. So in this example, you can kind of see how we'll do get stake, then prep stake, cook stake. Using .then, we could do it all pretty cleanly like this. And we're even checking for an error with the .then notation. So get stake would return an item, probably stake, that then gets passed into prep stake, and this just continues down. So hopefully this notation looks cleaner. And now we'll talk a little about promises. These are a little confusing, but basically a promise is like JavaScript, or you tell JavaScript like, sorry. When you try and get a promise, what's happening is you're saying like, hey, I'll need this value at some point. And JavaScript's like, okay, yeah, like keep doing your work. I'll get it for you. Don't worry about it. And it lets us do those asynchronous kind of operations. So when you create a promise, it starts in a pending state. So it's not like good or bad yet. It's just kind of like doing its thing. And then it's either fulfilled or rejected. And that kind of depends on like what happens on the back end of things. And this allows for continued computation while we're trying to wait for like an API to respond or a timer to finish. So we do have to change the way our functions work a little to implement promises. So here's that get stake function using the callback notation. And if we wanted to make it use a promise, we add, like we're returning a promise, which has a resolve and a reject as parameters. And then if we're like, yeah, this promise worked, we'll resolve it and return whatever. Otherwise, we reject it, it errors out, and we catch that error. Are there any questions about promises? It's a pretty dense topic. It's hard to kind of explain in one slide. Apologies for that. Okay, then another solution. This one's pretty clean. It probably looks most like what you're used to. It's async and await keywords. And this lets us write code that's asynchronous, but it looks pretty synchronous. And this is nice because it's like it looks like things we're used to, but it's working asynchronously. And to do this, we kind of break it into 3 parts. We first tell JavaScript like, hey, this function, it's going to be asynchronous, just so JavaScript kind of knows like something might be going on here. And then we give some await keywords. We toss those in the function, and that's kind of acts as a blocking behavior. So JavaScript, when it sees an await keyword, it waits until the promise is fulfilled before continuing. And then all of that goes in a try-catch statement, because sometimes promises fail. It's pretty sad when they do, but it happens. And I'll go through an example of async and await at the very end, but I did say like await's a blocking keyword. It basically means like, hey, JavaScript, wait here until we get a response. And like you might think blocking is pretty bad, like just waiting for the code to finish before moving on. But because we said the function is asynchronous, JavaScript kind of tosses it to that web API area and it continues working. So the function is blocked, but JavaScript itself isn't, if that makes sense. So those are kind of 3 general ways to get around blocking behavior and while still having JavaScript work pretty quickly. Are there any questions about those? Okay, awesome. So now we're going to get into HTTP a bit. And just before we do, like this is the backbone of how the internet works, which is kind of like crazy. Just one little thing. And, you know, we're sending messages across the world, speed of light. Like, it's pretty cool. So HTTP, what is it? It stands for Hypertext Transfer Protocol. And it is that gold standard of internet communication. Whenever you go to a website, you're kind of requesting it, or no, you are requesting it in HTTP or HTTPS, which just means secure. And you're basically just getting fancy text. So this protocol allows us to talk between servers and clients, where servers, they kind of store info and do things with that data, and clients usually like request the data and create info, and they'll send that back and forth, and that gives us the fancy websites we're used to. So requests in HTTP, it's kind of when a client's like asking a server for info or services. A request is made up of a method, a path, a version, headers, and a body. The important ones that you'll be using are the method, the path, and occasionally headers and body. So like most of them. But the method just tells the server like what the client wants. The path says where we want it. Headers might be a little more metadata about like who we are. And the body, we can pass a lot of info through the body as we're making these requests. So like, hey, I want a certain thing. I'll put that in the body before I send it off. And when a server gets that request, it'll take it, do whatever it does, and then send a response back. And a response looks pretty similar. It's made up of a version, headers, and a body, but it also has status codes and a status message. You may be familiar with like 404. That's kind of like, hey, this page, we don't know where it is. So that's a response from the server. 200 means like everything's good. 401, pretty sure that's forbidden. Like, hey, no, you can't access this. 500's like, shoot, the server's broken. There's a ton of these. You just kind of Google them when you get them to fix them. But that's kind of how the server and client talk together. So are we all perfect on HTTP? Okay, cool. So using HTTP, we're able to talk with APIs. What's an API? It's an application programming interface, which that's like not a great definition. It's just what it stands for. But that's like where you request info from the client to the server. Those are called endpoints. And that's a place where the client can pass data and get data from the server. And likewise, the server can get data from the client and pass it back to it. These are pretty similar to JavaScript functions in terms of you give it an input and you can expect an output that's pretty consistent. So an API like for Twitter, I might send it like, hey, get me this dude's account. So we'd say get, which would be the method, user is the destination, ID Zimba Boys would be in the body, and we'd throw that to Twitter, and Twitter would take it. They're like, yeah, I know this dude. And they'd send us a request back with all of this stuff in the body, which would be like my Twitter bio or just profile page. So that's a pretty simple example. But do we understand that communication between client and server? Okay, cool. So to kind of go even deeper into like what a client does and what a server does, the client side of things is what lives on your computer. So this is what you've been doing so far with HTML, CSS, and maybe JavaScript if you've gotten there. That's all living on your computer. It's performing all those like fancy pictures, putting them on your page. The server kind of serves a different purpose. It's a separate app living somewhere else. It could be on your computer, but think of it like a warehouse, like just a computer crunching numbers all day. It's built to serve data, and it serves it through those endpoints between the client and server. So I kind of talked about it a bit a second ago, but this is where we need async to come into play, because these requests, like the server might be super backed up or just on a slow internet connection. We don't know how long it's going to take to get our request and then send us a response back. And we do want to be doing things while we're waiting on that. So we have to use some async capabilities to do it. We can make requests using these 3 request types. There are more, but these are the most common you'll come across. There's a GET request, which is like kind of begging the server for data. You say like, hey, I want this, give it to me, and the server will. We can get more specific data, kind of like the Twitter example. I'm like, hey, give me Zimbo Boys' account, and Twitter or whatever server will give that back to us. We can also post data to the server, which is like, hey, we want you to store this. So we send it to the server, and the server usually takes it and throws it in a database. It might crunch some numbers with it. And put is really similar to post. It'll take data and overwrite a document if it's similar to it. So that'd be like updating your profile. Like if you change your name, you'd want to send a put request, so you don't like add another profile, you just update your name. So do the request types make sense? Awesome. So we can actually make these requests really simply by using the Fetch API. It's built into most browsers, not Internet Explorer, of course, but it lets us talk with servers super easily. We just have to give it a URL, and it'll figure out how to talk with that server. If we just give it a URL, it'll do a GET request, but we're able to pass in more options to make post requests, even supply like user credentials if we want to make secure APIs. And there's a ton we can do with it, but let's kind of just look at like using it as a GET request for now. So it's live coding time. So what we'll be doing here is getting a recipe from this endpoint. You'll be doing this soon too in your upcoming task, but this is kind of requiring us to make an asynchronous function call and communicating with an API that's been set up. So let's kind of see how we would do that. First, we'll want to put things in a function. And then call that function. So using the then notation, we could say like, hey, fetch this URL. After you get it, so that's the then, we're going to take whatever response we get and convert it to JSON, which is the JavaScript object notation that we kind of touched on last time. This is how servers communicate pretty quickly. So then once we've converted it to JSON, we'll take it, and then we'll just console log it, just so we can see it here. And boom, like that's all it takes to get data from a server. It's kind of a lot to look at right now, but this is just like one of the recipes y'all might have made. This one's for chili, so that's cool. But if we rerun it, we'll get hopefully a different recipe. Yeah, so we're actually making calls to a server with just this fetch and then kind of notation. So are there any questions about using the fetch API with a .then notation?
Why does it give you a different recipe each time?
Oh, okay. So the way we set up this API is to give us a random recipe. There's a way to get the same one over and over, but like, I don't know. I thought random would be a little more fun.
Okay.
Yeah, so that's how we do it with the .then notation. If we wanted to use the async await notation, we'd start off with a try and catch block, logging our errors as always. And within the try block, we'd say like, we want a response, and we'll wait for this fetch call to finish. That's what the await keyword means. Okay, and the error is telling me we need to make this a asynchronous function. That way JavaScript knows like await's going to be in there. So once we get that response, we'll convert it to JSON like this. So this is pretty similar to the .then notation, like first get the response, then convert it to JSON, but it looks a little more programmatic than just chaining a bunch of .thens together. And then once we do have our JSON response, we'll just log that to the console, and boom, we did it again, got our pizza recipe this time. So that's kind of a pretty quick overview of like how we can use fetch API to talk with the server, as well as use like our .then notation and async await. I kind of rushed through all that. So if there are any questions about that example.
What is the URL from? Or like, how'd you get that?
Yeah. So Elena actually set up like a server for this, like the Bootcamp project. That's just one of the random Amazon generated ones. I think it's a Lambda function or API endpoint or something.
Okay, so should we use that URL?
Yes, and it'll be in the project specs, so don't worry about like trying to write
Okay.
it down really quick. But yeah. There are tons of like URL endpoints out there. There's one like for random cat photos if you want to practice on that. But yeah, this one's pretty obscure, hard to read.
So you mentioned like using the then the sync await, and then promises. Is there one that you like recommend or prefer?
I kind of like .then just because like the periods all line up. That's not like a solid reason to like it. I think this one makes the most sense if I was like looking at JavaScript for the first time. Just because it kind of makes, to me, it makes sense like, okay, the response, we have to wait for the fetch to finish. We're not chaining commands together. But I'd recommend like trying both of them, seeing which one feels better, I guess.
Okay, makes sense.
Mm-hmm.
Kind of piggybacking off what Emily asked, in which situation is each of those like appropriate, the async and then the other one?
Anytime you're making a blocking function call. So for our cases, it'll mostly be for calling our APIs, because we'll have a front end for the user and set up our own backend server. But like between the two, I'm pretty sure they're identical in terms of how they function. I don't know if anyone has something to add to that. Okay, yeah. So my answer is like they're pretty identical. Just choose what feels better.
Okay, thank you.
Yeah. Okay, cool. So yeah, that was the fetch API. Hopefully that demo was like kind of comforting. Like, okay, it's not super hard to get data from a server and talk with it. To post takes a little more work, but you'll be doing that on your own. Yeah, so now it's your turn. Let's see what your tasks are for this next week. So between now and next Tuesday, or maybe later, we'll see if the deadline gets extended. Definitely not a hard deadline. You still have that first JavaScript task of like changing the recipe serving size and amount of ingredients, but you'll also be talking with that API Elena set up and getting a random recipe and then actually like making a web page for it. I guess I'll show you my little example here. So, you know, my nice site, you'll be making a random recipe page where when you go to it, it calls the server and it gets a random recipe. So like each time I click it, something new. In addition to just getting it and making it look nice on your page, you'll also have the ability to post a rating to it. So it's like avocado toast, 1 star, and you can see it goes down. So it's pretty two-way at this point. And you're able to post like a lot of ratings. Don't mess up the data too much, please. Kind of trusting y'all on that one. But that's like the general spec for this next part of week 2 task. And all the info on how to use that API will be on Notion. And a lot more resources on getting set up to actually use like JavaScript to make those calls from your front end. We'll toss more on Notion because I know that was kind of just a quick run through of all that. Any questions about the tasks? Okay, cool. As always, you can DM me or any director or post in one of the Bootcamp channels if you have questions. Office hours are going to be on Discord this week, 10 to noon on Saturday. If you can't make that, message me. Like, I'm free a lot of the time, so I'd be happy to help. I told y'all project feedback is coming soon. The specs for this will be posted in like 2 minutes. I wrote them up before the meeting, yay me. And yeah, we will be throwing more resources up. So that's all I have. Thank y'all for sticking through that. I know like that was probably a ton of info. So thank you again. Yeah, that's all I have.
Thanks, Ethan.